Welcome back to another thrilling episode of Mr. Hawkins' math class from his dining room. As I introduced in the previous video, we're continuing and looking at circles, and we're looking at lines and circles at the same time, and we are focusing on what's called a tangent line. So these notes will be about the tangent lines and different properties of those today. So a tangent line is a line that intersects a circle at exactly one point. That one point is called the point of tangency. Not a real original name. And we'll be focusing on this concept over the next several minutes here. So a line that intersects a circle at 2 points, again, this is a tangent line here. If it intersects at 2 points, it's not called a tangent line, it's called a secant line. We're going to be coming back to secant lines, but right now we're going to look at just tangent lines. So the secant line will be another lesson. This is just going to focus on that point of tangency. So theorems about tangent lines, it says if a line is drawn to a circle and a radius is drawn to the point of tangency, then the tangent line and the radius are going to be perpendicular. So again, if I draw a radius to the point of tangency, it makes a right angle. If I draw a radius to the point of tangency, it makes a right angle. And that's going to allow us to do certain types of problems. It's going to end up making right triangles where we're able to use the Pythagorean theorem. So that's one of the theorems we're going to look at and use today. Another theorem we're going to look at today is when you have two tangents to the same circle from the same exterior point. So here it says if two tangent segments are drawn from the same point outside the circle and are tangent to the circle, then those segments, now we're just focusing on this segment here and here, those segments work out to be congruent. So that's this and this. So same thing, again, same exterior point. Now if I focus on this segment and this segment, again, they're going to be congruent as well. They're always going to be the same distance. And there's certain types of problems we can do with those. Wonderful application of these two properties down here, like I said, here's a tangent and a radius. Again, that's going to create a right triangle. And of course, in right triangles, we could always use the Pythagorean theorem. So tangent segments and radii create right triangles. And again, you can use a squared plus b squared is equal to c squared because they are right triangles. So over here, they want me to find this distance from here to here, which is y. And I can just plug the legs into the right, or for a and b. So it'd be 5 squared plus 12 squared equals y squared. And so y squared would equal, what is that, 144 plus 25. That's 169. Square root that, so that distance is going to be 13. So because it's a tangent and a radius, it makes it a right angle, which makes it a right triangle, which means I could use Pythagorean theorem to find the missing distance. And you could do it again on that triangle over there. So circumscribed polygons, so some terminology. So focusing on this first triangle, or drawing here, I have a triangle on the outside, circle on the inside. That means the triangle is circumscribed because it's on the outside. So if you ever hear that word, it's on the outside. Circumscribed. The circle's on the inside, so that is inscribed. On the second drawing, now I have a quadrilateral on the inside, circle on the outside, so that means the quadrilateral is inscribed. And the circle is circumscribed. Just for this unit, note, in this unit, all lines that appear to be tangent are totally going to be tangent. So you don't have to like prove that it is or anything like that. So different types of problems we're going to see here. Again, tangent and radius, again, this is always going to give us a right angle right here. Because of that, I have a right triangle, which means I could use Pythagorean theorem. Determine whether the segment is tangent. So if you don't know if they're tangent, it should be a right angle, which means it should fit into Pythagorean theorem. So 9 squared plus 40 squared should equal 41 squared. So again, this is going to be 81. This is what, 1600? 41 squared, that's 1681. So when I add those together, 1681 is equal to 1681. So that means that that line has to be tangent. Must be tangent. Because it's fitting into the Pythagorean theorem, it has to be a right angle. Over here, Again, they want to know, is that line tangent? It would have to be a right angle here. If it was, that would mean 4 squared plus 12 squared should equal 13 squared. So this is 16 plus 144. That's 169. So when I add 16 and 144 together, that is 160. It is not equal to 169. So that means this is not tangent because it's not a right angle. Down here, if it looks to be tangent and 3 and 4 is a different type, you can assume they are tangent. Up here they wanted to know if it was tangent or not. So this is a little bit different. You know it's tangent, you know that's a right angle. So you can do 15 squared plus 20 squared is equal to x squared and solve for that. Over here, you're going to see problems like this. Notice where this x is. X is the distance from t to u. That's not the whole hypotenuse here. So what I'm going to do is I'm going to use the fact that RU is a radius. Well, I know radius is 15. All the radius in this circle are going to be 15. So I would go like that. So now I'd use Pythagorean theorem and say leg squared plus leg squared equals hypotenuse squared. But now I have to square x plus 15. So I'm going to have to FOIL that. So 15 squared plus 36 squared, I'll just do that on my calculator. That is 1521. This, I'm going to have to physically FOIL this. So the first would be x squared. The outer would be 15x. The inner would be 15x. So that's 30x. And then the last would be, what, 225? So now I have this quadratic. So to do a problem like this, again, I'd have to make it equal 0, so I'd have to subtract this over to this side. So I'd end up with x squared plus 30x. And then I would have, what, 225 minus 1521. And that's 1296 equals 0. So in that scenario, then I'd have to try to factor this. You know what? I'm not going to give you one like this. Don't do that one. So you're not responsible for this. Just so you know, I'm never going to give you one like that. But I will give you one like this for number 5. 5, I have a tangent, 2 tangents to the same from the same exterior point. That means these are going to be equal to each other. So again, once you know that they're tangent to the same circle, you can set these equal to each other because of that one theorem we went over. So then subtract 5x, add 3, that means x is equal to 2. So that's the way you would do that type of problem. Same thing over here. This is 2 tangents to the same circle from the same exterior point. That means these are going to be equal to each other. So that would mean 3x minus 6 is equal to x plus 10. Subtract the x, add the 6. 2x is equal to 16. That means x is equal to 8. A fan favorite type of problem here is these where you're asked to find the perimeters of these circumscribed polygons. So it means I have to find all these distances and add them up for each of those. And for each of these, what we're going to do is we're going to use that one theorem that said if you have an exterior point to the same circle, these are all exterior points to that circle, you're going to have these congruent segments. So that's going to be congruent to that. This is going to be congruent to this. And this is going to be congruent to that. Knowing that, I'll be able to figure this out then. So let's see. I've got to figure out how big x is. So let's see. X is this whole side right here. Part of it is 13. I've got to figure out what this other part is. Well, because this is the exterior point, this part side is 10. This side over here must be 10, which means x is going to be 13 plus 10. So x is equal to 23. Number 2 wants me to figure out how big this segment is right here. So let's see. I know that this is an exterior point here. This is 18, which means this has to be 18 over here. So now I could just do 26 minus 18. And that means this part is 8. If that is 8, that means x is also 8. And on number 3, figuring out what x is. Again, same exterior point. This has to be equal to that. So that means 2x should equal 8, which means x is equal to 4. On number 4, wants me to figure out what this third side is. Let's see. From this exterior point, this side is 4. That means this side's also 4. this exterior point, if this is 6, that means this is 6 over here, which means the length of 10 would be, or length of x would be 6 plus 4, which is equal to 10. X here, again, this part of it would be 2, this part of it would be 6, so that's going to be equal to 8. Then down here, figure out what x is. Those two have to be equal, so do x plus 2 is equal to 8. Subtract 2, x is equal to 6. Problem like this down here, I have two tangents to the same exterior point. I'm looking for the angle between them. I know this central angle is 117. Tangent and radii are always going to be perpendicular to each other. So basically I have a quadrilateral where I have 3 of the angles. I'm missing the 4th. Again, they all need to add up to 360. So this one would be what? 90 plus 90 plus 117 plus, I don't know, should equal 360. So that means all I got to do is subtract all of this out of 360. So let's see, 360 minus 90 plus 90 plus 117. And that's 63. Here they want me to find the perimeter of the distance around the shape. So again, I'm using these common exterior tangents. If this part of it is 15, so is this part. This part of it is 8, so is this part. So this whole side would be 23. If this side is 10, this side would also be 10. So that means this is 18. This side over here is 25. So then I just add all these up. So that means this is going to be 18 plus 25 plus 23. So 18 plus 25 plus 23. That is 66. So the perimeter of that would be 66 centimeters. That's the way you do a problem like that. And then there's the pulley problem. The pulley problem goes like this. You got to keep your eye on the tangent. So basically you have a pulley system where you have a wheel spinning, another wheel spinning, and a belt going between them. You're going to be asked to find the distance between the centers of these circles. So to do that, you're going to use this tangent, which they're telling you is 35 inches. You're going to use these radii as well. So now you need to visualize in your brain this tangent line right here. And in your brain, I want you to slide that tangent line down these radii. You're going to slide them towards the centers. So you're going to slide that green line, the green tangent line, and it's eventually going to stop when it hits the center of the small circle, right there. So it's going to slide that distance right there. It slid a total of 8 inches down that radius, which means it slid 8 inches down here, which means that it still has 6 to go on that other radius. So now you can form a right triangle like this. This remains 35 inches. I slid 8 inches down a 14-inch radius, so I'm left with 6. And you got to keep your eye on this right angle. That right angle staying right there. So now the distance between the centers turns out to be the hypotenuse. So I can use Pythagorean theorem. 6 squared plus 35 squared is equal to x squared. So I'm going to do 6 squared plus 35 squared, and the square root of that, and that's 35.5. 35.5 inches. So that's the way you do a pulley problem. So then I have a series of problems down here for you guys to try, similar to the ones that we just did. A couple pulley problems for you guys to try as well. The answers to these are in the completed notes within the same folder, so you can check your answers as you go. And then I have a small homework assignment for you guys to work on. But again, basically tangent lines and radius, you're worried about a couple theorems. The one theorem is a tangent and a radius are always perpendicular. That's the one thing you're worried about. The other thing you're worried about is that two tangents to the same circle from the same exterior point are always going to be congruent. And then you're going to be asked different questions about those. So again, finish up these notes, check your answers on the completed notes in the folder, and then see if you guys can do the homework. All right, thank you very much.